Hey guys, lesson 6 in unit 2, looking at the homework problems. We have a car that's traveling down the highway at a constant speed. That's a tip that it's going to be proportional. And we can describe its relationship between distance and time with this equation. D equals 65t. D is representing distance in miles, and that car is traveling at a speed in t hours. So, helpful thing for us is to put hours and miles in a small table to see that hours is represented by T and distance is represented in miles by D. So this is the setup of what that equation gives us. Now the equation also tells us what the constant of proportionality is, because it says you can take 65 and multiply it by T to get what D equals. So we are interpreting that equation in table form to help us get our mind wrapped around this problem. So what does the 65 tell us in the situation? There's a couple of things you can write here. You could say it tells us the constant of proportionality. It also tells us that we go 65 miles in 1 hour, right? It's telling us that. We could say it's the speed of car. We could say constant of proportionality. Lots of different things we could say that number is helpful for us. Very helpful. How many miles it goes per hour. How many miles does the car travel in 1.5 hours? So if we put a 1.5 here, we would simply need to multiply that by 65 to find out what that amount is. So we can do that. 1.5 times 65, and that will give us, in an hour and a half, we expect it to go 97.5 miles. 97.5, so 97.5 miles. And then how long does it take the car to travel 26 miles at this speed? So working in reverse, let's use a different color here. We want to go 25 miles. We are continually going at this 65 mile an hour speed, but to go back the other direction, we need to either divide by the constant that we currently have or multiply by its reciprocal, which is what I'm going to do. A 65th of 25. So 1/65 multiplied by 25 should tell us how long it's going to take us to go that amount. And that is 5/13. All right, let's convert that to 0.4. Yeah, let's round that to about 0.4. 0.38. I like hundreds. So about 0.38 hours, which is equivalent to, let's go ahead and convert that, times 60, because there's 60 minutes in an hour. It's going to be about 23 minutes. About 23 minutes to go 25 miles, which makes sense. 60 mile an hour, you'd go a mile a minute. Number 2, Elena. Elena has some bottles of water that each hold 17 fluid ounces. Write an equation that relates the number of bottles, B, to the total volume of water, W, in fluid ounces. Okay, so I'm going to set up a table for this. We're going to call B, these are the bottles, right? And W is the volume of how much water. Okay, so this is volume, and this is bottles. We know that one bottle will hold 17 fluid ounces. So there's our relationship. We should be able to easily get our constant from that relationship, right? This is all for the purpose of writing the equation, just to kind of get our head wrapped around which letter we multiply by. Okay, so when we write this equation, what we're going to do is we're going to see that the B is getting multiplied by 17 to equal what the W is. So I'm going to write W equals 17B, right? And that you could have also written the backwards version of that, B equals a 17th W, acceptable, both of those. How much water is in 51 bottles? Well, you'd have to do 51 times 17. Let's do that real quick. 51 and 17's product is 867. So 867 fluid ounces would be that amount. How many bottles does it take to hold 51 fluid ounces? Okay, so this was 867. I'm expecting this to be a few bottles, right? Because we need to either multiply by a 17th or divide by a 17th divide by 17 to find out what that is. I'm just going to divide by 17. And it would take us 3 bottles to be able to do that because 3 times 17 is 51. So 3 bottles. Number 3. There are about 1.61 kilometers in a mile. So let X. All right, so obviously we're going to have a relationship here. So let's go ahead and set up a table for this one. Okay, so let's let X represent distance. So X is our distance in kilometers. Sorry, kilometer distance. And then we're going to let Y be miles. So Y is in miles. There we go. And it says 1.61 kilometers is the same as 1 mile. All right, so I can start to see my constant being times 1.61 to get over. Now I can read the rest of the problem knowing that I have a good grasp of what's happening. So X and Y represents those things. It wants us to write 2 equations that relate a distance measured in kilometers and the same distance measured in miles. Okay, so we have to write 2 equations for this relationship using Y, X, and then, of course, 1.61. So what I'm going to do is I'm going to start with the easy one. Y times 1.61 will equal X. So X will equal 1.61 times Y. The other one is going to be Y equals something times X, and that something is 1.61's reciprocal. So to show you how to do that, since you are using your Desmos calculator, let's jump to that one. So let me go to Desmos here. All right. And we want 1.61, and we want that in fraction form. You can see it there. And then if we flip that, it would be 100 over 61. All right, so 100 over 61. You can see it's a really ugly number. So we're going to leave it as just 100 over 61 for our purposes. So 100 over 61. All right. And that is the reciprocal. If we go back, you can see 1.61 was 161 over 100. Oh, that's supposed to be 161. I'm sorry. Maybe that's why it came out weird. There we go. Still comes out weird. But it would be 100 over 161. My bad. So 100 over 161. Sorry about that. Okay, number 4. In Canadian coins, 16 quarters is equal in value to 2 toonies. Canadians have some weird names for their coins and for their money up there, obviously. So toonies are coins that they have, and it takes 16 quarters to equal 2 of them. We have the relationship shown here. We can spot a constant pretty easily with multiplication by 8, right? So the first thing that it wants us to do is fill in the table. So something times 8 equals 16. 2 times 8 equals 16. I know this would be 3. And these 2 blanks are going to be like in between numbers, right? So if multiplying by 8 gets me over there, I should be aware at this point in what we've been doing that multiplying by an eighth or dividing by 8 would get me across there. So I'm going to do 20 times 1/8. And 1 times 1/8 would just be an eighth of a toonie. So that's easy enough. 20 times 1/8 would be the same as 28, right? 20 times 1 is 20. And then I can reduce that down to 18. 8 will go into 20 twice with 4 left over. So that would be the same as 2 4/8 or 2.5 for you decimal lovers out there. Okay, so we have our table filled out, and then it asks us, what does the value next to the 1 mean in this situation? So it's asking about this value right here. Okay, this is our constant of proportionality. Okay, that's what it is. And it really represents, the value of a toonie per quarter, right? It is the value of a toonie, which is a fun word to say. The value of a toonie per quarter, right? It takes 8 toonies to make a quarter. And so 1 quarter would be equivalent to an eighth of a toonie. And that is your homework help for lesson number 6.